Good day, everyone. This is Mayflower. It's been gone through 6 years and 60,000 miles. The vehicle is extremely reliable, but at the same time, it's also a good time for me to complete a makeover of the electrical system. And that was done recently, about a couple weeks ago. So, what kind of electrical system I like to have? I like to have the electrical system look just like this. This is a maintenance-free. The electricity go into your house. You never have to worry about the availability of electricity. It's easy to operate. Everyone who owns a house knows how simple it is to operate switches and lights and computer charging, as well refrigerator, so on and so forth. So let's take a look at the changes I made to this system so that it's carefree, just like the utility company getting electricity into our house. So this is the basic design diagram change. If you take a look, this is the battery. I add up the total battery is about 800 amp hours. 800 amp hours of a lithium battery compared to the factory or OEM is only 400 amp hours. So I doubled the capacity of the lithium battery. And the OEM battery has a charge side and also a discharge side. So it's a two-sided system. But the new design I have is only a single-sided system. It's all common side. The charge and discharge side are actually combined into one. And this is the kicker battery. There's a lot of discussion about the kicker AGM. And I really don't need the kicker AGM in my system. But it's because it's already here, so I kind of leave it alone. And then this is the unhood generator and charging. This could produce a 280 amp, very high powered underhood generator. And this path is the DC path. And then down here is the AC path. Okay, so the AC path is very simple. It has a 200 amp inverter. And then the circuit breaker, the receptacle, and whatever switch is needed to turn things on, like a coffee pot. You turn on the switch, it'll turn on. And I also have a hot wire surge protector from Shore Power. So Shore Power come in, it go to the surge protector before it go into the inverter. And the inverter is controlled by a single switch. I changed the switch to a lighter switch, so I could know the inverter's on or off. So this is the AC path, really simple. By the way, the inverter is also a charger. I turned the charger off because of the legacy problem. I like to leave the inverter on the discharge side. That's why I turned the charger off. Because if it's on the discharge side, try to charge on the discharge side is not good. So I leave the inverter, so I leave the charging function off. And if we go to the DC part of the circuit, it goes to a 60 amp circuit breaker. And then this is the additional charger that I put in. It's the brand is the Iota 15 amp Shore charger. And this Shore charger kind of takes place of this inverter charger. But now because I have a common side, I really don't need this. I kind of keep it in here because I like the cooling system it has. It has a fan, and I'll show you later on why I do that. And this is the solar charging panel with the controller, EP-Ever controller. And then I added a crank charger. The crank charger would charge the chassis battery automatically. And so that this way, if I don't drive the vehicle, the chassis battery is fully charged at all times. This is very simple to do, but if you don't know how to do this, Northeast RV now have started to install crank charger for owners. So if you want a carefree system that the solar could always charge your chassis battery, you could go to Northeast RV and ask them to install this for you. Okay, so this is the DC path, and there's a switch, on-off switch, and the switch would drive a relay, and the relay would go to turn on and off the DC going through the fuse panel, and then it will be the DC load come with on-off switch, like the light switch, such as this. You have the light switch, the LED light switch. So it comes with the on-off switch to turn the load on and off. At the same time, I also install a small inverter to drive the television, because this inverter is very inefficient for low power consumption. It is okay if I use it for air conditioning or microwave or coffee maker and as such, it is okay. But use it to drive the TV is not efficient at all, because the TV would use less electricity than the overhead of the inverter. So I install a separate TV inverter for it to make it very efficient. So this is the original latching relay, but this latching relay is broken. It does not latch anymore, and I try to find another latching relay with that particular circuitry in it, and it's difficult to find. So I decided to design my own relays. So instead of a electromechanical relay, I designed a solid state relay. So this is a solid state relay. It also has a low voltage protect cutoff, so that when we drain the battery down, for some reason, if we forgot to turn off this low for months, it could drain the battery down. But when the battery gets down to 11.8 volt, it will disconnect the relay so that it will stop draining or damage any of these batteries. So this is what I added into this relay. It's a solid state relay. So let's first of all take a look at the crank charger. And the crank charger is tied to the solar controller, and I have an MT50 to show you how does it work. So this is the MT50. Let me turn on the light. Okay, so this is the MT50. Right now, as you can see, the left hand side is a solar panel. It is charging at 1.8 amp to the battery system that I have, 2.4 amp to the battery system, and from the solar and the battery system, it feeds 0.2 amps into the chassis batteries. So this is like a chassis battery. So 0.2 amp is going to the chassis battery to maintain the parasitic on the ProMaster RAM chassis battery. If I don't have this arrangement, the chassis battery would discharge in 2 to 3 weeks. So if I don't use a vehicle for 2 to 3 weeks, I will not be able to start the engine after that. But with the crank charger in place, this could run for years. You could leave the vehicle under the sun for years, and the chassis battery is still full and ready to be cranked. So let's take a quick look at the crank charger. What does it look like, and where did I store it? So this is where I put the crank charger in. This is the crank charger. So this is the crank charger, and I also could check the voltage of the chassis battery. So the chassis battery right now is 13.3 volt. So this is the crank charger tied to the solar controller. Very easy to do and install. So this is the crank charger. So we're done with the crank charger. Let's take a look at the battery system, the lithium battery system that I put in place. So this is the chassis, this is the battery systems. I have a 200 amp hour JK track, and I also have a 304 amp hour and 304 amp hour, two of them. So this battery has been redesigned completely from the factory battery. So this is the box for the factory battery, and I happen to have the age vintage. So this is the age vintage factory battery. I completely gutted everything and put in this brand new latest cells. These are 304 amp hour EVE cells. EVE is likely the second largest lithium cell manufacturer in the world. And I also have the JK BMS. The JK BMS is worldwide popular, very capable, 200 amp and fully functional. And this is a JK BMS, and it comes with the solid state contactor, so I don't need to put in contactor in here and there anymore. And as you can see, because this is a common sided design, so I only have a positive and a negative, and that's it. I don't have to charge or discharge side. So this is not used, and I kind of use this as a bus bar if I need to, because this is a nice screw and I could put connection on the outside and use it as a bus bar. So I have two of this. And before that, the very first design I put in is the JK track. The JK track was the very first that I used the JK BMS. That's why I call it the JK track. And I could check the JK track battery now. And I could turn on the apps, and okay, this is the app for the JK track battery. Let me put it up here. So if you look at the battery, it is 100% charged right now. It says 100% charge, 200 amp hour capacity, and the cells are almost perfectly balanced. It's only 0.001 voltage difference. So the blue is the high voltage and the red is the low voltage. As you can see, the difference is 0.001, extremely well balanced. And if you want a good battery, they gotta be well balanced. And this battery has been turned on for 1 year and 260 days. So 1 year and 260 days. So this is the kind of battery, has very, very low overhead. So you could turn it on and forget it. It's a phrase coined by another owner in the Facebook group. He called it turn on and forget. And this is exactly the kind of idea we want to do. So this system, you turn everything on and you can forget about this and just use electricity. And how do you use electricity? You have the DC power switch. This is the DC power switch. And the DC power switch, also there is an AC power switch. So you could turn on DC as well as turn on AC. And as you can see the path, they are independent of one another. You could have one on with the other off, or vice versa. They don't have to be both on. But I usually keep the DC on and then the AC off if I'm using the vehicle if I'm not using a vehicle, I turn both of them off to save electricity. So this is the equivalent of the circuit breaker in your house. So if you have a basement, most of the time your circuit breaker panels are in the basement. So you could turn it on and off, and then that's it. You turn them on and off, and then you could use the independent light switch, fan switch, a refrigerator switch, whatever. So it'd be very simple. There's no more worry about, should I turn this on or off? Should I do reset or not? And do I need to turn on these or off this to have under generator or shore power charging? With this design, charging and discharging is all done in the background, so you don't have to think about charging and discharging. If you want to use it, you just turn it on and turn it on. And if you leave this on or leave this off, charging is happening continuously. Okay, you don't need to worry about it. Charging is happening continuously, just like a utility company. You don't worry about, is the generator in the utility company is producing electricity, so you don't have to worry any of this, and just use it and enjoy it. Okay, so these two batteries was mounted in the original place under the chassis, and I put in the JK track, the 200 amp hour JK track, more than a year ago, almost 2 years ago, in this location. So this is where the JK track is, and it's been on for more than 1 year, close to 2 years. Very easy to put it in. I drilled 2 holes on the floor and connected to the charge junction and the chassis ground. So this is the JK track 200 amp hour chassis battery using the same original factory 200 amp hour cells. Okay, and next I want to show is the stuff inside the inverter cabinet. So this is the inverter cabinet, and this is my work light, and this is the 15 amp standalone charger that is a legacy design. I leave it on because it has a very nice fan, and I make a duct so that it would cool the cabinet without concern about anything. And as you can see, it says Mayflower, and there's a slot for the airflow to come in and out. So one of them is the inlet, and this is the outlet. Okay, so that's how I cool the system. And this is the Power Watchdog surge protection, and I installed it inside the cabinet so that I don't worry about if I put it on a power post outside, somebody might walk away with it. So this way it's safe to locate it in here. And this is the solid state relay that I use to replace this. And this is the broken one, electromechanical. This will make a noise clunk to turn it on, but this is broken, it doesn't work. So this is the solid state relay I use to replace it. And underneath it is just a DC power bus bar. So I run a wire underneath the chassis instead of take it off from the inverter terminal, so that the DC power is not drawn down by the inverter usage, so that the voltage will be indifferent based on the indifferent somewhat. It will be slightly droop when the inverter's on, but it's much less because the cable comes directly from under the charge junction, from the underneath the chassis, not from the inverter terminal. So this is my inverter cabinet, and the light would automatically go off when I shut the inverter door like this. The light would go off, and I open the inverter door, my work light will come on. So this is the inverter cabinet. And now let's go take a look at the other component, and I give a demonstration of the AC power usage. So let's go to the front there. Okay, and clear everything in here. So this system look very similar and looks the same to most people, and this is the new 304 mAh battery I put on. It says 100% state of charge, and as you can see, I changed the inverter switch to a lighter switch so that I could tell when the inverter is on or off. At the same time, I added a light to here for the DC power. So this is AC power, DC power. If I shut this off like this, the lights would go off. The voltage display would also go off. And a couple times I left this on at night and forgot about it because I did not install the light before that, and it was late at night and I cannot see the reading, so I totally forgot about it. So adding a light would help to remind me the DC power or DC low is still on. So I remember to shut it off to reduce the low. And this switch is no longer a toggle, no longer a intermittent switch. On the original factory is an intermittent switch. You push it, it will come on, push it, it will go off. But this is now a toggle switch. So toggle on and toggle off. So it's a different kind of switch. The reason I changed the switch is this is what's required for the solid state relay, because it's not a latching solid state. It's a conventional solid state low power disconnect. It's a very good system that I designed. You probably don't want to go through the trouble to design it yourself, but if you want, the circuit diagram is in another video I uploaded in my YouTube video account. And like everything I talk about today is already in the YouTube video, so if you're interested in anything, you could go to the YouTube video or to take a look or copy it yourself, but at your own risk. Okay, this is at your own risk, but I have spent a lot of time to test every design that I put up, and it's been very, very reliable so far. So the last thing I want to do is to show you the